Hello everyone, my name is Omar. Welcome back to the channel. I hope you guys are doing absolutely fine. Very happy new year to all of you guys. I hope 2021 brings a lot of prosperity, well-being and joy in our lives, and we learn more and we grow more. Right, so well, that's it. Let's continue this video. So this video is a continuation, or you can say it's a part 2 of the VLAN video which I had uh, released earlier. So if you haven't watched the VLAN video, you can watch. The link is in the description below. Well, so continuing with the second part. So in the first part, what we did was we created VLANs. So we broke down the physical broadcast domain into, we broke down the single broadcast domain into multiple smaller broadcast domain by creating VLANs. So when we created VLANs, what happened was PCs now which were connected to the same switch and a part of different VLAN, they could communicate only with the host which were in the same VLAN. So if a host is in VLAN 100, the host can communicate with any other host which is a part of VLAN 100 or the same VLAN. Similarly for 200, similarly for 300. Now today we will discuss about how to span this VLANs over multiple switches. Now when you talk about that, so you have some other options also available. So let's forget we have a trunk written over here. Let's forget about trunking. Let's say what other alternatives we had. So the other alternatives which we had was I can connect a cable from this switch to this switch, another cable. So I can connect two cables and I can connect a third cable also. And what I will do is I'll make this cable a part of VLAN 100, this cable a part of VLAN 200, and this cable a part of VLAN 300. My job is done. So now if any PC or any host belongs to VLAN 300, it will use this port. It's an access port again. It will go to this switch and it will communicate with VLAN 300 over here. Again, you have any other host in VLAN 300. But is it feasible is the question. The answer is no, because if you have 10 VLANs, you'll be wasting 10 ports just to move your VLAN information from one switch to another switch. Now to avoid this, we have a concept of trunking. Now what is trunking? Trunking is having one path from one switch to another switch, and what this path does is it tags anything which is going across. So what this will do is if you are going over here, it will just tag you that you are a part of VLAN 100 or VLAN 200 or VLAN 300. So let's say we have a tag associated now. If this is the third packet, it will be having a tag of 300. So any frame which is going from one switch to another switch over the trunk port, it will be tagged or it will be encapsulated with a header which will specify which VLAN do you belong to. Now when you talk about tagging, so what kinds of tags were available? So you have two kinds of tags. You have the .1q tag available and you have the ISL tag available. Now .1q is nothing but 802.1q IEEE standard. So I'll just write it IEEE over here, and this stands for inter-switch link, and inter-switch link is a Cisco proprietary tagging method. This will add an ISL tag. If you say it adds a 28-byte header and a 4-byte tail. Okay, here in .1q you add a 4-byte tag, and where does this 4-byte tag come? So here between your source MAC address and the length type, you add some 4 bytes like this. So this is your .1q tag. It has two type, 2 bytes for the tag type and 2 bytes for the control information, and everything is written over here, so you can refer to the diagram to understand the header. So on your frame you have a tag of 4 bytes which specifies that which VLAN do you belong to, and when the switch receives a tagged packet, it opens that packet, it checks that yes, you belong to VLAN 100, and then it will send the packet to the right destination. So if a packet originates from 200, let's say for 200 we use a blue tag. So you have a blue tag over here, it comes to this switch, the switch removes this tag, strips this off, and it will send the packet to VLAN set the frame to VLAN 200. Right, so the VLAN are spanned across multiple switches. So this is the theory of how it works, and now we will go and configure this thing in a lab. So in the lab, we have taken a similar scenario, another similar scenario, we can say is the same scenario. We have two switches, we have three PCs each. Each PC belongs to a specific VLAN. We have VLAN 100, 200, 300 on one switch, and on the second switch also you have three VLANs. And if you talk about the IP addresses, it is 10.1.1.1, 2, 3, 4, 5, and 6. So before we start doing anything, let's go and check whether the VLANs are configured properly or no. I'll just try to ping over here. The ping won't go. Obviously, that's not the method to check it. The method to check would be to go to the switch and check the VLAN assignment. Let's do that. So I'll go back to the switch and I'll just type in show VLAN brief, and it shows me that I have VLAN 100, which is having port 0/1, VLAN 200 on port 0/2, and VLAN 300, which houses port 0/3. You see, port 0/24 is in VLAN 1, and this port number 24 is the connecting link between these two switches. So on the other switch also, let's go and check the same thing. So show VLAN brief, and it shows me that I have 1, 2, and 3 configured in VLAN 100, 200, and 300. Right now, even if I try to ping from VLAN 100 to this PC in VLAN 100 again, it won't go because this port, the port which is connecting these two switches, is a part of VLAN 1. So obviously it won't, and it's an access port. We haven't configured it to be a trunk port yet. Now to do that, let's go on this switch and do the configuration for the trunk port. So let's access the CLI config t interface f0/24. One command in this version of packet tracer, it supports only .1q encapsulation, and in most of the environments you will be just seeing the .1q encapsulation. Two reasons: one, it's less overhead, and the second reason is obviously it's open standard, so it will support all your devices. ISL, more overhead, and it's Cisco proprietary, so well, it runs only on Cisco switches. And in this particular software, it does not really support the command where you can set the encapsulation. In the actual Cisco switch, you can do that. So the command for that would be switch port trunk encapsulation. Choose the method of encapsulation you want, 802.1q or ISL. And then the next command would be to configure the port as a trunk port. So switch port mode trunk. That's it. Right. If you want to be very, very specific about what VLANs you want to allow and what VLANs you don't want to allow, you can do that as well over here. So I can just write in switch port, sorry, not port security, switch port trunk allowed VLAN, and I'll say I want to allow only 100 and 200. I do not want to allow, let's say 300. I'll allow it later on, but for now I don't want to really do it. And let's go and check show interface trunk in the configuration. So it shows me f0/24 trunking mode on, native VLAN 1. I'll talk about native VLAN in a bit. Okay, allowed on trunk only 100 and 200. So 100 and 200 are allowed on the trunk port. I'll go and configure the same over here. But before I configure, let's go and check. Show interface trunk. Nothing is there. Okay, cool. So config t interface f0/24 switch port mode trunk, and switch port trunk allowed VLAN. Let's say I'll again make it 100 and 200. Okay, and now let's verify the same command, show interface trunk, and it shows me that I have 100 and 200 allowed on my port 24, which is configured to be a trunk port using the encapsulation method of 802.1q. Now what I'll do is this PC 10.1.1.2, and again the corresponding VLAN 200 PC is 10.1.1.5. So let's go and try to ping from 10.1.1.2 to 10.1.1.5. And yes, there is communication between the same VLAN. Obviously, there's no inter-VLAN routing, so it won't go and just ping PC 5, which is 10.1.1.6, part of VLAN 300. Right, and now you see in this trunk port, I have allowed only VLAN 100 and 200. So if I try to send a ping from VLAN 300 PC, which is 10.113, all the way to 10.116, the ping won't go, because that is not allowed to go over this trunk port. So ping 10.1.1.6, and the data does not really flow through. So what I'll do is I'll just go and allow that VLAN as well. Why to leave him out? So by default, everything is allowed. So you can just write switch port trunk allowed VLAN all, or you can just leave it so it will allow everything by default, or you can be very specific as what you want to allow and what you don't really want to allow. So I was just being very specific just to show you guys how this thing works. Sorry, config and comma 300. Right, so now let's go and repeat the same thing. And yes, now I do have a reply coming in from the other PC. So well, this was the concept of trunking. Now what is left is the concept of native VLAN. So in the concept of native VLAN, what really happens is I have an option of configuring one VLAN, right? So one VLAN as native. And when I configure that one VLAN as native, that frame goes untagged. So frame goes untagged, right? So if by default the native VLAN is 1, so I'll just write what is the default native VLAN. Default is 1. So anything going for VLAN 1 is not tagged. It is just sent as it is. So you'll just see a frame going like this. And when this switch sees that there's no tag, it will go and check what is the native VLAN. And it will say that, okay, native VLAN is 1. So this belongs to VLAN 1. If I configure a VLAN as, let's say, 10 as my native VLAN over here, and if I configure native VLAN 20 over here, this is wrong. It will show you an error message that there's an inconsistent native VLAN across the trunk port. So please go and correct it. If this would have been the case, that you could have tagged VLAN 10 as native over here and VLAN 20 as native over here, this would lead to VLAN leaking, wherein if a PC from VLAN 10 sends something to the switch and it goes untagged, obviously, so 10 is going untagged, this switch will receive an untagged packet and it will assume that it is going to be a part of VLAN 20 and it will send it to a host in VLAN 20. So this would be leaking the information. So VLANs are, the information is getting leaked from one VLAN to another VLAN, and hence it is not allowed. It was in those old days it was allowed to do that, but in current iOS versions you cannot really do that. Well, so this was all about VLAN. So we have covered VLAN. We have part 1 where we talked about how to configure VLANs, and in part 2 we talked about how to span VLANs over multiple switches. I hope this has been informative. You can drop some comments in the comment section below. You can share the video. Do subscribe to our channel and stay tuned for more videos coming in on networking. Till then, take care. Bye bye.